In this lesson, we're going to go over using Hive with the HDInsight for Azure distribution of Hadoop. For the most part, the process is the same using Hive on HDInsight for Azure as it is for using any other distribution of Hadoop that includes Hive. The primary differences are the way we reference external files and that we're probably going to use a web console instead of a command line interface. If you're not familiar with how Hive works, there's another lesson that deals directly with that and kind of explains what Hive is doing and what its process is to create MapReduce jobs and return results. And I'll put a link to that lesson in the notes below this video. So if you're not familiar with Hive, you want to learn more about it, please go watch that video as well. And for this example, we're going to use some weather data that I've previously uploaded into the Azure Storage Vault, which is in the Azure Blob Store. So again, this is data that's stored outside of the HDInsight Hadoop VMs and is accessible either from those VMs or from external tools like Cloud Explorer that I'm using here. And you can see that each file that's in the folder here is about a gigabyte. So in total, if I add all that up, I have about 12 gigabytes of data, which isn't terribly a lot for a Hadoop system. But for the purposes of this video, we want to keep it so that it queries in a reasonable amount of time. But the file sizes are pretty much reasonable. About a gigabyte per file is pretty reasonable size for a production system. So next, let's create the Hive tables that we can use to query with. And what I've done is logged in already to my HDInsight web console. And from this console, I can jump off and do a lot of different things. Within the interactive console, there's a JavaScript side of it. There's also a Hive console. I'm going to click on the Hive console. And if I type in the show tables command, I can check and see what, if any, tables I have in the system right now. And this is a freshly deployed system, so there's really nothing here other than this Hive sample table that HDInsight put in there for me. So I'm going to run a create table command, which is very similar to what we might do in T-SQL for SQL Server, but it's in the syntax called HiveQL, which is the Hive's SQL syntax. It's almost ANSI. It's pretty close. We have a few clauses, create external table US daily weather. So that's internally, I will call that US daily weather when I use a select statement, which you can actually see down here already. The keyword external means that Hive needs to know that it doesn't manage these files. So it's just pointing at some files that are already there. If I should drop this table later, then because it's an external table, Hive won't try to delete that data in any way. So it just kind of knows it's pointing at some data. It doesn't really own it. Then, as with any SQL, we would have a list of columns that are in this table. The data types that you use in this create external table statement are more or less the data types you would find in Java. I think we can expect in future versions of Hive for this to get tightened up a little bit and reflect a little closer to the ANSI SQL we're used to. But for now, just use the HiveQL reference to look up what data types you're going to use, and most of the time it's going to be string, int, float, and so on. The next clause is describing how these rows in the table, or how the rows in the source data is laid out. And my tables are CSV files. They're just simple comma delimited. There's no text qualifier, so none of these fields have commas within the data. I know that. So I can just specify that this is delimited by comma. Very easy. And then I tell it it's a text file and the location. The location, if you see, is the ASV. So it's a Azure Storage Vault syntax, essentially telling the HDFS system that this is out in the blob storage. That's where you should go get it. And again, the format of this is bghdistorage.blob.core.windows.net. It's kind of your storage account name. The weather is the container within that storage account, and the US Daily is the folder. And if we look within Cloud Explorer, we can see how that URL is being formed. So to run this, I'll just take this first statement, which will create the table. And of course, it doesn't really create a table, it just creates some metadata. I'll paste that into the console and click the evaluate button, which essentially means execute. Then in response, I will get kind of an echo back of what was sent to Hive, as well as the results from that. So I can see that this did finish, and the time taken to create the table was about 0.8 of a second, which seems okay. So next we're going to run a couple queries. I'm going to run one that runs pretty quick, and then I'm going to run one that runs a bit slower, because I want to illustrate what Hive is doing isn't really querying a database engine the way we might expect in SQL Server, Oracle, or Teradata, What it's actually doing is allowing us to use SQL to generate MapReduce jobs that eventually run in Java. The responsiveness of our query in Hive v1 is going to depend on how performant those underlying MapReduce jobs can be. So the fastest thing you can do in Hive is to do something that just runs a mapper and doesn't have to do any shuffle or reduce. An easy example of that would be a query that just returns like the top 10 rows within the table. So I'm going to do that. So this command selects star from US daily weather limit 10. Only needs mappers just to go out and read a few rows. No reduction because there isn't a group by, there's no sums or anything that would require any further processing or reduction of data. So when I run this command, it should return reasonably fast. And there we have our returns. We have the first 10 random rows that were found by some random mapper within our table. Not a very useful thing to do except just to verify that the data does come back. And we can see it took about 2.2 seconds to run within our 4-node cluster, which is pretty reasonable. The next query I'm going to run is this one. And this query is select count distinct station key. So in this case, the same station might be distributed among a whole bunch of different nodes. So a reducer is going to be required to take all of the station keys that each node finds and then reduce them into one distinct list. So we know this will be a map and reduce job. And furthermore, is going to require all of the data to be read in order to satisfy this request. So we have, what did we determine, 12 gigabytes of data. So the mappers are going to have to pour through 12 gigabytes of data in order to answer this question that we have. Go back to our console and paste that in, and then again hit the evaluate button. And now what's happening is Hive is taking our SQL query and is making up a plan to answer this question using essentially Java MapReduce programs that are submitted to the cluster. So it'll run through the mappers on all of the data nodes, or at least as many data nodes as Hadoop decides to use. And once all those nodes process their data, it'll come back to probably a single reducer to get my distinct count of how many stations there are in this table or this set of files within the state of Michigan between the beginning and end of the year 2011. So I'll speed the video so you don't have to wait the entire time, and then we'll take a look on the other side. Okay, our job is completed, so we can see that this is the statement that we entered and was passed on to Hive, and the answer is 490 stations. So we waited a while to get one number, but it's important to recognize what had to happen in order for that number to pop out. All of these files needed to be read, processed, filtered, and then that final filtered list from every data node had to be consolidated through a reducer job. On the right-hand side of the console, we can see the output from the MapReduce jobs. This is going to be a little bit easier to read within the job log, so I'm actually going to go and look in job history and find this job, and I'll look at it here so I can see the command that was run, what the output was, 490. And then this is the standard error that came out of the MapReduce process, and we can actually see the map and reduce steps that continued on down, and at the end this took 104 seconds. For a SQL server with that much data with a lot of indexes, remember that that would maybe not be fantastically performant, but for a system to process through 12 gigabytes of text files in order to come up with that answer is not too bad. And if you think about the complexity as a user of what we had to do in order to generate that, was just to write some very simple SQL. Okay, that's our intro to Hive on HDInsight for Azure, and hopefully that gives you a sense of the process to go through to create tables and query them. Fairly straightforward, fairly simple, and the web console makes it pretty accessible for analysts and for administrators.